Alrighty, hello everyone, and welcome to our CSG lecture for this summer, an introduction to network forensic tools. For those of you who don't know, my name is Adam Isaac. I am our current incumbent president, and I'll be presenting our lecture today. So if you're attending live, thank you for showing up for this meeting. If you're watching later via YouTube, please don't forget to like and subscribe, right? All that good stuff. So without further ado, let's go ahead and kick things off. So to many, including me, networking kind of seems to be like this dark magic of technology, right? Information moving from point to point at nearly the speed of light does seem kind of hard to comprehend. However, magic or not, gathering useful information using networking tools can be very simple. While both of the tools that I'll be introducing today were used as part of NCL, I find them very useful in everyday cybersecurity and networking tasks. So today we'll be talking about NMAP, a network mapper, and Wireshark, a packet analysis and capture tool. So let's get started with NMAP. So what is a network mapper exactly? So a network mapper allows users to scan an entire host or subnet to determine which of those hosts are online and the services that these hosts provide via the network. This information is extremely valuable to both security professionals looking to perform reconnaissance and administrators looking to monitor their network. So I've got up on our slide here, I've got an example screenshot of the output of NMAP, which is a command line tool, in case you hadn't gathered. So if you want to scan a host, you might scan an IP address like 192.168.3.8 or ius.edu if you're using DNS, or you could just as easily scan an entire IPv4 or IPv6 subnet, as I've demonstrated directly below that. So let's take a look at some of the common options that NMAP offers from its command line. So for starters, you can use the -p flag. Let's see if I can annotate here. I'm gonna say probably not, unless. Yes, I can. So we've got our -p flag here. It lets you specify a list or range of ports that you're interested in scanning. So by default, NMAP, I believe, goes 1 through 1000 TCP. This will let you narrow down or even widen that range. The -a flag performs what's called an exhaustive scan. So that's going to make sure it's going to gather the maximum amount of information possible against whatever host or subnet you throw it at. Obviously, that's going to be rather loud, so it's going to be rather noticeable. So there's a trade-off there. We've got the SU flag in case you want to perform a UDP scan instead of just TCP. So obviously by default, NMAP prefers TCP just because that's what the majority of web services are available via. It's a transmission control protocol, but UK is very much capable of scanning UDP as well. And of course, we've also got -SN just to perform a ping scan. So that's useful if you want to do some quiet reconnaissance just to see what's there and what's online and what's responding. We've also got, finally, we've got a -6 just to enable IPv6 scanning, which is off by default. So obviously, I'm not giving you an exhaustive list of options here. There are a large number of them. If you'd like to take a look at some of the others, you can find more information at this link here that goes to NMAP's wonderful documentation. So let's take a look at how exactly we use NMAP by taking a look at an example in NCL question. So here's a question that might be asked on NCL. What is the lowest TCP port open between 1 and 1000 on iuscsg.org? So I'll give you all a minute to try that on your own. And then while you're working on that, I am going to pull up a terminal window and show you how I would go about accomplishing this task. Just give you guys another minute or two. All right, so the very first thing we're going to do is, since we're in our command line, we're going to want the nmap command. I don't want you to see that. Basically, yeah, you can kind of see the answer in my history there, but we're going to do nmap, and then we're immediately going to specify either our IP, our host name, or our range. In this instance, that's going to be iuscsg.org. And then just it works, since the question actually gives us a specific port range, we're going to do -p and give 1 through 1000. We don't need to specify any other flags here because by default, NMAP is going to perform a TCP scan, which is what our question here is asking for. If it asked us for us to check the lowest UDP port, we need to add -SU to tell NMAP to do a UDP scan. But we're not going to do that. So we're just going to press enter here and see what it tells us. All right, so if you take a look at NMAP's results, it gives us the latency to reach the host. It gives us reverse DNS information, which may or may not prove useful. It shows us that tells us that of the ports we scanned, 998 of them were closed or filtered, so NMAP wasn't able to scan them. And then you can see we have 2 TCP ports open. One of them is port 80 TCP, and it's NMAP's determined that's used for HTTP, so web traffic. And the other one is 443 TCP, which is used for secure web traffic. So therefore, the answer to our question here would be port 80. And if we click over here onto our PowerPoint, we can see that is correct. All right, so moving on, we'll take a look at our next and slightly more powerful tool called Wireshark. So so obviously, as I mentioned before, Wireshark is what's called a protocol packet analyzer. So what exactly is a protocol packet analyzer? So Wireshark allows you to view and make sense of all network traffic visible to the machine doing the capturing in a somewhat human readable format. And I know you're kind of thinking, well, how is that useful? So this allows you to recover some passwords, files, and other information that's being sent over the network. So say if you were able to somehow intercept and decrypt someone's password from their workstation to whatever remote server is doing the authentication, you've managed to successfully grab that user's password. So that could be extremely useful in a cybersecurity type scenario. Or if you're some sort of developer and you're not understanding why some of your traffic's going missing, Wireshark may provide you a low-level view into what's going on. So there are lots and lots of different tools to capture and analyze traffic, but I've chosen to feature Wireshark here because it seems to be the most common, and it's also cross-platform. I've also mentioned here on the slides that Wireshark operates at the data link layer of the OSI model. If you don't know what that is, don't worry about it. It's not important here, but if you've taken a class like CSCIB 438, that's computer networking with Dr. Doyle, that may provide some good insight into exactly what Wireshark is doing under the hood. So it's little enough theory. Let's go ahead and take a look at the GUI. So this is Wireshark's GUI, and this screenshot was taken immediately after Wireshark was launched. So this is your basic startup screen. To start capturing traffic, what you do is up here in box number 1, you can see you can insert a traffic filter here to specify the ports, hosts, and other information that you're interested in order to cut down on some noise. Because by default, Wireshark just shows you every single bit of traffic it's able to see over that interface. So for example, I might insert host equals 192.168.168 101 destination port, I don't know, 80. If I wanted to see all web traffic, unencrypted web traffic that was being sent to that host in particular. So down here in box number 2, you can see a list of the interfaces that are available to the computer. Up here, first one, in this screenshot here, the interfaces are Linux named interfaces. So that may appear a little bit differently on your machine. But here on my system, you can see we have a WLP29SO, which I know is a Wi-Fi interface. You can see we have any, so that Wireshark will capture any traffic. We've got loopback, an Ethernet, ENP25SO, Bluetooth, and a few others that I won't discuss in huge detail. So to get started, we'll punch in that filter, choose our interface, and Wireshark will immediately jump into the next screen, which we'll see what capturing traffic looks like. So this is what Wireshark looks like after you begin capturing traffic. Let's see. When Wireshark's capturing traffic, it's displayed in real time here. In box number 1, we can see the header of the table with the packets laid out. We can see the packet number, its time offset since when we started capturing, its source IP, the destination IP, the protocol of the traffic, the length of the packet, and some of the information in a human readable form, which I've highlighted here in box number 2. In box number 3, you can see we have packet number, which packet number is this? 4 highlighted. And in box number 3, it shows us sort of the different packet layers. So you can see we've got a frame here, we've got an Ethernet frame here, we've got IP packet information here, we've got TCP packet information here, and finally at the highest level we have LDAP information, or lightweight directory access protocol, which is the traffic that's actually being captured here, along with a little bit of Kerberos traffic. So if you look closely, you can actually see in the first 3 packets, you can see the TCP 3-way handshake that's performed. You can see a SYN, SYN-ACK, and then an ACK, just like Dr. Jules discusses in his networking class. And then below that, we can start to see the actual protocol information that's being analyzed. So you can see a little bit of LDAP traffic, some of the LDAP queries actually being performed. You can also see some traffic labeled KRB5, which I know is Kerberos traffic, which is also a different authentication system. If you're not super familiar with all of these protocols and everything, don't worry. It's super important that you know what all of them are to understand Wireshark, but it certainly helps. So moving on to our next slide, we will take a look at an example NCL question featuring Wireshark. So in this question, I've provided an example packet capture file that you can download to your machine and open in Wireshark. I would highly encourage you to do so, because I'm going to help so you can follow along with me. And I have our example NCL question here, which is, what is the username of the first user that attempts to log in via Radius? Now, Radius, it's not essential that you know this, but Radius is a popular network authentication protocol. I'm not going to get into the details of what exactly that is, but I am going to walk through this question with you in my own Wireshark instance. So give me just a moment to pull up Wireshark. You should be able to download the file to your computer, launch Wireshark, and go to File, Open. Let me show you exactly what I'm doing here. Already, you all should see my Wireshark instance. This is the default start screen. You can see all of my interfaces here. Since we already have the traffic captured for us, we're just going to go to Control, Open. I know I've got the information in my desktop folder here. And you can see we've got radius localhost.pcap. And as soon as I open it, you can immediately see the traffic contained in this file. So we're going to sort through this traffic to try and find the very first authentication request made. So if I fold down this here, we can see our frame information, which is really, really low level information that's probably not useful. We can see it was sent over the null loopback interface, which is probably not important for this one. You can see our IPv4 information. We can see our header checksum's incorrect. That doesn't matter here. Oh no, this is IP information, not bad. And we can see this went from source 127.0.0.1 to 127.0.0.1, which usually means it went over our loopback interface to the exact same host. We can see our UDP packet here. We've got our checksum, timestamps, and a payload. And then finally, we have our application information radius. You can see this was an access request packet. And we can also see, if we unfold all of these boxes, we can see attribute value pairs, AVP, username, value equals Steve. So that means the answer to this question was Steve. And I'll click through a few more of these just to give you an idea of what else you can see in here. If I just scroll through, click on a different request, we can see the same information. We can see there's an encrypted user password that Wireshark's not enabled to decrypt. We can see there's other radius specific information that I'm not super familiar with, but may be useful depending on your knowledge and what's asked of you. I can also right click and go down to follow UDP stream. This might be able to give you a lot more useful information. If you're looking at something like HTTP, you might get actual full text transactions here. So if I was, say, requesting HTTP, you might see actual HTML in the screen, whereas this footer down here just gives you low-level packet information. So that's two very, very useful things to know when you're using Wireshark. Let's flip back over here. All right, so a few notes about that question. In the example data that I showed you in Wireshark, there was absolutely no noise. There was only radius traffic. That is extremely unrealistic of both real life and, in my experience, NCL questions. Part of the battle is having to hunt through the information, all of the ARP requests, all of the background traffic going on in the network to find what you want. Usually you're going to want to accomplish that with filters and things of that nature. I've also covered a very small set of Wireshark's features here. Wireshark is capable of many, many other things, including extracting unencrypted files from the network traffic, all kinds of things. So if you're really interested in finding out more about Wireshark, I encourage you to check out this link here. Should lead you to Wireshark's manual, which is wonderful and gives you exhaustive detail on everything Wireshark you could ever imagine. And finally, Wireshark is capable of analyzing much, much more than traditional network traffic, including even Bluetooth and USB traffic. So be on the lookout for that. So we've taken a look at NMAP, a network mapper, and Wireshark, a packet analyzer. These are two network forensic tools that I find most useful for competitions and cybersecurity. I highly, highly encourage you to work more with these tools on your own time. If there are resources or assistance we can provide to make this easier, please don't hesitate to let us know on Discord or to shoot me an email. With that said, thank you for coming by. If what I've discussed here really, really interests you, I encourage you to look into taking CSCIB 438, Fundamentals of Computer Network by Dr. Doyle. It covers everything I've talked about here and more in exhaustive detail. If you're an officer, please stick around after this meeting, this presentation for the officer meeting. If you have any questions, please feel free to ask them now. Alrighty, I'm going to take that as no questions. If you all, if you think of anything later, don't feel free to reach out via Discord. This video will also be posted on YouTube at a later date if you'd like to refer to it later. So thank you for attending, and I will see you next time.